It's it is Mercy David's Education again, and today we are talking about the need for a transport system. So higher organisms like plants and animals have a transport system. Plants have vascular tissues made of xylem and phloem, while animals have blood vessels and sometimes a heart to pump the materials. So why is it so? Now we are going to look at surface area to volume ratio. Now we are going to calculate the surface area to volume ratio of the different potato tubes. We are considering those tubes that to be our potato tubes. Now when you look at the surface area of a tube has 6 equal faces. So if we get the area of one face and we multiply it by 6, then we get the surface area of a tube. The volume of a tube is simply side times side times side. But before you go ahead to calculate the surface area to volume ratio, imagine potato tubes of different sizes are completely immersed in iodine solution, and the time taken for iodine solution to diffuse to the center of the tube is determined. In which tube will iodine reach the center earliest? Of course, in the smallest of the three of them. So let's go ahead and calculate the surface area to volume ratio. Just like I said, if you get 6 times the area of one face, then you can be able to get the surface area. Volume is simply side times side times side. So if we get the surface area and we divide it by the volume for each tube, we can get those values which are down there. 0.75 for the biggest tube, 1.5 for that middle tube, and then 3.0 for the smallest tube. So what do you notice there? Although the biggest tube has the highest area and volume, it has the least surface area to volume ratio. All we are saying is, although the biggest tube has the highest volume and area, it has the least surface area to volume ratio. So what does surface area to volume ratio mean? Now, it means how much outside surface is available to allow simple diffusion of materials required by a unit volume. In this case, the biggest potato tube has a surface area of 0.75 square millimeters to allow simple diffusion of materials needed by every 1 cubic millimeters. It can be seen that for the smallest tube, the inner volume has a lot of surface area outside to allow in the required materials by simple diffusion. That's to say that each 1 cubic millimeter of the smallest tube has an area of over 3 square millimeters to allow materials to diffuse into that volume of 1 cubic millimeter. This explains why iodine delays to reach the center of the biggest tube. Imagine the potato tubes are organisms of different sizes. Imagine that the iodine is oxygen, glucose, amino acids, etc., required by all cells, including the innermost cells. For higher organisms, it would take long for materials necessary for life to reach the innermost cells. Equally, wastes like urea, carbon dioxide from the innermost cells would take long to leave the organism. Specialized exchange surfaces such as the lungs, intestines, and transport systems with specialized channels as blood vessels in animals, conducting tissues in plants, allow materials to reach distant or inner cells faster than they would with simple diffusion over the body surface. So that is the need for a transport system, so that materials are easily delivered to the inner surface or to the inner cells with less disruption. So you can continue following us Master David's Education, exploring science beyond limits. If you like our videos, please like, comment, and share.